our previous class, we talked about secret sharing scheme. So we have given an example here. For example, it is the binary secret was there, and dealer was trying to distribute this secret among these two, boy and the girl. And we have shown that this is considered to be a perfectly secure secret sharing scheme. That means even if this girl and this boy will have some extra information like this shared, then also as a single participant, this girl or this boy will not have any extra privilege over the outsider who does not even have any share. Then we extended this idea to Shamish's secret sharing scheme, and it was like a polynomial based secret sharing scheme, and we have explained all in details. So in today's class, I'm going to give you another very important example of secret sharing scheme, and that's very interesting and very easy to understand. This secret sharing scheme that is known as visual cryptography. Okay. So let us try to understand in that way. Suppose the secret is INRIA. This is a black and white image. And this secret, the dealer wants to distribute among two participants. So what the dealer is going to do, the dealer is going to do like this. So the dealer is going to give two participants two shares. Now note that these shares are nothing but something random looking things are printed on some transparent sheets. So they are the transparent sheets, and on that transparent sheet some square box are printed, and you can see that some dots are printed over there. Okay, so two participants are there. Each of the participants will be given these two shares. That means two printouts on, mind that, on transparent sheets. That means you can see me through this transparent sheet. Now the question is, what will happen when both the participants will come together? Suppose these two participants, they come together, and what they will do, they will just superimpose one after another. That means they do have two different shares. Now what they're going to do, they are just going to superimpose one after another properly. Okay, now you see that something is there written over there. Can you see this now? Can you see this? I'm not sure how. Is it visible to your screen?
Yes, sir. India.
Okay. Yeah. So now you can see that if both of them, they are superimposed, you get the INRIA back. Okay. All the things that you are doing here is basically doing the things visually. That means just eyesight is sufficient and the steady hand is sufficient. That's why this scheme is known as Visual Cryptographic Scheme. In short, we call it VCS, Visual Cryptographic Scheme. So we started with a black and white image, and then we made it in two shares. That means taken on the transparent sheets. And when they are superimposed, you get back the secret INRIA. Okay. Since this is done visually, the whole scheme is known as visual cryptography, and that's very easy to understand how to make this kind of schemes. Okay, so let us come to the basic idea how it's being done. So this is based on the whole, now the talk will be based on my three publications. So they, all of them are published in Design Course Cryptography. They are very well-known journals for cryptographic schemes. Okay, so let us try to understand how that can be done. Okay, first thing, we first note that suppose we consider any image. Suppose this is my black and white image. Okay, suppose this is my black and white image. So if you zoom any of the images, so then the size of the image will increase, and ultimately it will be distorted. And when you have zoomed it for its maximum level, you will ultimately find that there are some boxes are there. Okay, so every image is made up of some boxes. Suppose you want to have some grayscale image. In my last class, I have mentioned that the pixel values are lying between 0 to, if this is my pixel value, then this value will lie between 0 to 255. Okay, this means complete black and this means complete white. And in between, if you have, suppose this value is say 100, then that means it's more towards white. That means some gray effect will be there. For example, when we draw some images, usually we give some shade. So suppose this portion is blacker, you can understand that this portion is blacker than this portion, because both of them are black, but this is more blacker than this portion. Okay. So here also this pixel value, depending on the intensity of the pixel, it will vary. So if you zoom some grayscale image, you will find that ultimately it will have some boxes. So at this point of time, if you consider this, you can see that this is complete white. Say up to this, suppose you come here. So in that box, you can see that it is some portion is black, some portion is white. That means suppose this is that part where you will find that this portion is black and this portion is white. That means this intensity value may be in between of black and white, say 120. And suppose this portion is completely black. Suppose you consider this pixel, then you suppose this is completely black. Suppose it is here, you will find that this is a complete black. Suppose this is 255 and so on. So if you zoom it, you will ultimately end up with few boxes, and each of these boxes are known as pixel. Okay. So this pixel value for grayscale image, this pixel value lies between intensity lies between 0 to 255. But for purely black and white image, these pixel values are either 0 or 1. So these pixel values are either 0 or 1. Okay. 0 means white and black, 1 means black. So suppose this is my complete black and white image. So you can understand that this pixel should be 0, this pixel is also 0. When it comes here, suppose this is black, it will be my 1, and so on. So I started with some black and white image. So Inria was my that image. So this is my black and white image. Okay. Now let us try to understand how did I understand, or what is the basic idea behind that. Suppose I have this black pixel and I print it over a transparent sheet. Now if I ask you a simple question, suppose I am taken a printout, suppose this is my an A4 size paper, and suppose I have written something on black and I have printed out. Okay. Now if I ask you the question, and this is my black and white printer, I took this printout from a black and white printer. Okay. Now if I ask you a question, why usually we take the printout on a white page and not on a black page? Why this is so? Why we take the printout on a black and white paper and not on a black paper? Anybody?
Sir,
Yes.
hello. To get
Yeah.
the full spectrum of the colors.
Okay. So what will happen if you take this on the white paper? You will have something written black here. But if you take on a black paper, then what will happen? Background is black and the ink is also black. So you may not be able to distinguish between these two. That means there will be a contrast difference problem. So the background is black and you are writing it on a black thing. Then you will not be able to visualize this because there will be less contrast difference. But if it is on white, then suddenly there will be a huge contrast difference. It's completely white and this is black. But the main point is, suppose on a black and white printer, you have written something on white. Suppose this is written on white. And you have you ever checked what will happen? Suppose in case of a when you wrote down something, this portion was white, right? So for black and white printer, do you really think that it ejects some white color on the paper? What I'm again repeating the question. Suppose you have taken a printout of this writing. Say this is written on black ink and you are taking a printout. So this portion is white. Now when you are going to take the printout, do you think that this black and white printer eject some white ink on the white portion, or it leaves just black ink on the black portion? Any idea? Whether for white portion, does the printer ejects some white color on it?
No,
Or
sir.
yes. So for black and white, if it is a color printer, then it might be the case that for white portion, it may eject some white ink. But since this is only a black and white printer, for white portion, the the printer will not eject any white color. That means white portion remains as it is. So now you will be able to understand that suppose I have drawn a black square on my paper and I take a printout on the transparent sheet. I have taken a printout on the transparent sheet. Now what will happen? There will be a black portion on the transparent sheet, no problem. But if I have, say, a white box here, no demarcation, that means the printer will not eject any ink here. That means it will remain just the transparent sheet. Okay, I can see it. That means for black, it will eject some color on it, but for white, it will not eject anything. That means it will be like this white portion. Okay. Now, when you are going to superimpose this over this, and if you see like this, then as a result, what you will see visually, you will get a black color. So this is printed on one transparent sheet, and this is printed on another transparent sheet. So black colors are ejected here, but nothing is ejected here. That means this is just a simple transparent sheet without having any color. But this is a black transparent sheet, or some portion black color is being ejected on this portion, and here nothing is ejected. Now if you superimpose one after another, and if you see as an effect visually, what color you will see? You will see a black color. Is it clear to this step? Is it clear to all of you?
Yes, sir.
Okay. Now what happen if both of them will be black? Then you will visually see the black color. If one is white, another one is black, then you will also see as a black. But if nothing is printed here, nothing is printed here, you will finally see nothing is printed over there. That means white over white, that will give you white. Now, can anybody be able to tell me what are the mathematical operations? So this is a physical phenomenon, right? What are the mathematical operations are being done here?
It's OR operation.
Very good.
Black is 1 and white is 0.
Very good. So if you consider black to be 1 and white to be 0, then what will happen? So you are considering black to be 1. So your black is 1 and transparent is 0. As an effect, what you will get? You will get 1. That means 1, 0 gives you 1, 0, 1 gives you 1, 1, 1 gives you 1, but 0, 0 will give you 0. So that is nothing but binary OR operation. So in Boolean, we usually studied this binary OR operation. So at that time, when we studied this binary OR operation, we may think that that might have only applications in some physics, OR gate, NAND gate, XOR gate, etc. But this is a physical phenomena where you can very easily use this concept in case of our visual cryptography. Okay. Now you can think the same thing could also be done, like if you consider black to be 0 and white to be 1, then what will get? You will get black, that means 0, then 1, 0, that will also give you 1, and sorry, that will also give you 0. Then if it is, say, both of them are black, 0, 0, then also you will get 0. And if both of them are white, then also you will get white. Okay. So can you tell me what is the operation for this? What is this operation?
Is it NOR? NOR operation?
Zor.
Just have a look at this. XOR. Any idea?
NOR. NOR operation.
And
This is AND operation. So that's why this is just the complement of this. See, this is the complement of this, and I have just complemented it. Where it was 1, I put it 0. If it is 0, I put it 1. And as a result, I get just the opposite thing. Wherever it was 1, I get 0. Wherever it was 0, I get 1. So this is now the AND. But in our visual cryptographic purpose, we will consider the OR operation. That means we consider 1 to be black and 0 to be white. Okay, is it clear? So now you can understand that this is a physical phenomena that can be very easily explained through this. So superimposition of 2 pixels is nothing but mathematically it's the OR operation. So that is our first observation. Okay. Next, the question is, how did I make this? Let us try to explain the whole algorithm. So note that here what we are going to do is to construct the 2-2 scheme. So I hope you remember what do you mean by 2-2 scheme? 2-2 scheme, 2-2 visual cryptographic scheme. That means there are 2 participants and if both of them they will come, so this is our T and this is our W. 2-2 means if both of them will come, then only the image should be recovered. But if at least one of them or one of them will come, they should not get any information about the secret. That we have to show. And that will give you the idea that how this concept is known as perfectly secure secret sharing scheme. Okay. So let us try to understand how it is being done. Okay, suppose this is my black pixel. And the dealer wants to give this black pixel among 2 participants. Say this is participant 1 and this is participant 2. So what the dealer is going to give? The dealer is going to give for the first participant 2 pixels, 1 black, 1 white. Similarly, for the second participant, he gives 1 white, 1 black pixel. So these 2 pixels are printed on this transparent sheets. For this pixel, for 1 black pixel, this is printed on the transparent sheet. Okay, so this is one transparent sheet, and for this is another transparent sheet. I have printed. Now, when they are going to superimpose one after another, what they will get? They will get, as in visually, what they will see. Suppose this is superimposed over this, then what they are going to see?
2 black
pixels. Okay. Now this can also be done in this way. So here we had taken first black. So instead we can take first white and then black. And so there, what should I put it here? What should
black
I put?
then white.
Very good. And then when they are going to superimpose, they will again see 2 black pixels. Now what's about for white pixel? So for white, the first participant will be given 1 black, 1 white, and second participant is also given 1 black, 1 white. When they are going to superimpose, what they will see? 1 black, 1 white. Now this can also be done by 1 white, 1 black. So what should I put it here?
First white, then black.
White, then black. So when they are going to superimpose, they will see 1 white, 1 black. First note that for 1 pixel, I am giving 2 pixels to each participant. So for 1 pixel, I am giving 2 pixels to each participant. Not only that, for black, I am getting 2 complete black. But for white, I am getting 1 black, 1 white, or 1 white, 1 black. Now, how this is understood? If you look at the secret image, so in the secret image, it was a complete black and white image. That means the background of India was white. But if you look at the background of this superimposed image, you see that this is a grayscale, but still there is a difference, so that we can at least visualize the INRIA quite easily. But the background here, it was gray. It was white, complete white, but here the background is gray. Note that also the size of the INRIA is also increased. Here the size has increased a bit, and that is explained through this fact. For black, I am getting complete black in the superimposed image, whereas for white, I am not getting complete white, but a black and white mixture. And visually, that is actually reflected through the fact that the background is gray. Okay. Also, note that for 1 pixel, I'm giving 2 pixels. That's why the size of each of the superimposed image or the shares has increased. So for 1, I have given twice. That's why the size has also increased. Note that why we are going to distinguish the image, why this INRIA is visible. That is important. Why the INRIA is visible? Why? If you look at here, for black pixel, I am getting 2 black. But here I am getting, in both the cases, I am getting 1 black. As a result, there is a contrast difference. For black, I am getting more black. For white, I am getting less black. As a result, visually, we have some difference of 1 black, which is reflected through the fact that this background is gray, whereas this INRIA, this writing, this each of the alphabets are complete black. As a result, visually we can distinguish, and I have already shown you this is not done in machine, but you can by hand, you can do this. That's why one of the advantages of this scheme over any secret sharing scheme is that here, while recovering the image, you do not need to calculate anything. Only your steady hand and your steady eye are sufficient to get back the image. You don't need to do any mathematical operation, unlike Shami's secret sharing scheme, where you need to calculate something. You need to solve some system of linear equation, then you need to calculate things and so on. But here, nothing is required. Only a steady hand and a steady eyes will help you to get the secret image. That's why this scheme is known as Visual Cryptographic Scheme. Okay. Now I need to prove that, okay, from 1 share, we should not get any extra information. Okay. So now you can understand why, if both of them they will come, why they will get back the secret, because they will have then the contrast difference. When superimposed, in case of superimposed image, there will be a contrast difference. Okay. So first, let us try to understand how the dealer will distribute the share. Okay. So you can understand that at each level, there are 2 ways. One, so for black pixel, you have 2 ways. For white pixel, you have 2 ways. Suppose in the original secret image, the first pixel is a black pixel. Okay. So what the dealer will do? So for this algorithm, the dealer will have as an input the secret image. So in my case, the secret image was the INRIA, the writing INRIA. Okay. So this is my black and white image. The dealer will see the first pixel of the image. Suppose the first pixel is a black pixel. The dealer will come here. Now the dealer has 2 ways to go. Suppose the dealer has some unbiased coin, and he decides that if he will get head, he will take this path, and if he gets tail, he will take this path. So he first have a look at the first pixel. If the first pixel is black pixel, then he will come here and make a coin toss. Suppose as a coin toss output, tail comes. That means he needs to take this path. What he is going to do? Now it will give 2 outputs. That means printing on some transparent sheets. On the first transparent sheet, he will print for the first pixel in the secret image black. He will print, since he has taken this path, he will print a white and a black pixel to the first transparent sheet, and to the second transparent sheet, he is going to print 1 black and 1 white pixel. Okay. Then again, he will look at the second pixel of the image, secret image. Suppose the second pixel is a white pixel. he will come here and he will again make a coin toss. Suppose he has already decided that if head comes, he will take this path, and if tail comes, he will take this path. Okay, so he will again make a coin toss. Suppose he gets head, then what he will do, for the first transparent sheet, he will print one black and one white, and to the second transparent sheet, he will put one black, one white. Okay, and again he will come to the third one, and suppose the third pixel is a black pixel. He will come again here, and again he will note that at each level he needs to make a random choice. So again he will make a coin toss. Suppose he gets head now, he will take this path. So to this first participant, he will print one black, one white. To the second participant, he is going to print one white, one black, and so on. And he will continue this till all the pixels of the secret image are exhausted. If all the pixels are exhausted, then your printing process on the transparent sheets are over. Now you just take the printout on this. So there will be just two files. You just take a printout of this, and then as an output, you will get this kind of transparent sheets, printed transparent sheets on it. Now when you are going to superimpose one after another, as I have already shown you, you will get back the secret image in real. Okay, now let us try to understand what will happen if one of them, they will come and he alone wants to guess what is the secret. Suppose this guy alone, he comes and he tries to guess whether his 2 pixel is coming from this black pixel or white pixel. So you can understand that it came from black pixel. Now if he is able to guess it correctly that okay, this came from black pixel, then he wins. So let us try to find what is the probability of guessing it correctly when only this guy tries to find it. Okay, now you can see that out of this 4 patterns, this pattern is also present here. Okay, so the probability with which he will able to guess whether it comes from black pixel or white pixel is 2/4. That means half. So with half probability, this guy will be able to guess whether this pixel corresponds to black pixel or white pixel. Now think about yourself. You do not have any share. You only know that each of the pixel is either black pixel or white pixel. Now tell me, what will be your probability of guessing it correctly, whether this pixel, whether the secret pixel is black pixel or white? Anybody? What will be your probability of guessing it correctly?
Half.
Is exactly half, because you know that the secret pixel is either black pixel or white pixel. So with probability half, you can also determine whether that is for black pixel or white pixel. So that means in our last class, what we have already explained, that in spite of having this shared with him, this guy will not have any extra advantage over the outsider who does not even have any share. That's why this scheme is also a perfectly secure secret sharing scheme. Okay, and this scheme was also invented by Shamir and Neor in 1994. Okay, so that is known as visual cryptography, and they have given this 2-2 scheme. Is the 2-2 scheme clear to all of you? Okay, so let us try to show and give a kind of demo. Let's see how it works. Anybody from you, can you tell me your name? Anybody from you? So I will write
Tamos, sir. Tamos. EAMS.
So suppose Tamos is my secret image. So I just want to consider, I just make it my black and white image. Now I run my programming. Okay, let's see how these shares are generated or not. So Tamos was my secret and few shares are generated. So here share 1, share 2, share 3. So I just took them up, insert images. Yeah, sure. Share 1. I insert here another share. Let's see. Insert image, share 2. Okay. So they are my two shares. Now I copy, suppose this share. So this is my share 2. I copy this share and I put it here. See, this is my one share and this is my another share. I just want to superimpose them. Now you can see that it is blacker. If I increase this, it is even blacker. If I superimpose them properly, you will get. Now if you just disturb it a little bit, you will not be able to see. You need to put it just one after another, then you will able to see this. Okay, now you can see that the background is gray, but here the background was prominent. The size of Thomas has also increased. The background was white, complete white there, but here the background is not white, it's gray, but still you can manage. And if you take the printout of these two shares on transparent sheets and if you just superimpose one after another, then you will also able to see the same effect. And that I have already shown you through one example. So anybody else want to put his or her name? Anybody? I can.
Oniket.
Oniket. Okay, let's see how Oniket will.
ANIKET.
Aniket. I need to just convert it into image. Okay. Okay. First, I remove this shares from here. And then I run the program with Oniket. Okay, the shares are generated. Now I need to include them. Insert images. Upload from. So this is one share. Okay, Oniket was there in the. Yeah, Oniket was there. So I need to insert another share. Insert image. Upload. Share 2. Now I copy this share and I paste it here. You get Oniket. Now if you just remove a bit, it will not work. But if you send it properly, the Oniket will come back. Now you can see that your name is also there. So the idea is you need to implement that. So that is one of your homeworks, how to deal with images and how this can be done. I have written this in Python. So this is my Python code, but you can also write it in C programming as well. So for that, you need to just check how this images are useful or how to read some image and do it. Okay. So any question till now? Any question? Any question till now? Okay. So, are you there with me?
Yes, sir.
Okay. So let us try to extend the idea. So till now what we have studied, it's basically for black and white image for 2-2 scheme. Now let us try to extend it, but before going to that, we need to have some mathematical idea known as basis matrices. Okay. So the idea is very simple, nothing more. So what you are going to do is that you just represent the whole thing black by 1 and white by 0. So this is 0 1, this is 0 1 1 0, and this is 1 1. Now what I'm going to do is that instead of doing all the things, I just make a matrix representation. What is this? So this is my first row of the matrix, that is 1 0, and this is my second row of the matrix 0 1. Okay. Now if you give a column permutation on this, what matrix you will get? Another matrix you will get. You will get another matrix of this form 0 1 1 0, right? If you just give a permutation on the column, you will have this as a, it was your second column, now it is your first column, and it was your first column, now it is second column. Now you see that it is 0 1, same as 0 1, and this is 1 0, this is 1 0. So what you understand, that the whole image, instead of doing that, you can write it like this: S1. S1 stands for black, so this is 1. So for this I write S1, a matrix named S1, and this is like this. The first row is this and the second row is this. And if I make a column permutation on it, I will get first row as this, second row as this. So it is sufficient to consider only the S1, 0 1 1, sorry, 0 1. Similarly, here if I write it like this, so this is my 1 0 0 1 1 0 0 1. So I call it S0 because it was my 0. So 0 is here. So 1 0, first row, second 0 is also 1 0. If I make a permutation of this, what I'll get? 0 1 0 1. This is my 0 1 and this is my 0 1. So what you understand is that the whole picture now be transferred into only two matrices. One matrix is S1, which was nothing but of this form 1 0 0 1 1 0 0 1, and S1 is 0, which was 1 0 1 0. Okay. Now in terms of these matrices, how the dealer is going to do? Again, we can see this. Suppose this is my original image, black and white image. The dealer will first look at the first pixel of the secret image. If this is white, the first pixel is white, the dealer will come to this matrix. Then the dealer will make a random permutation on the column. So there are two elements here. So either random permutation on the columns mean either this will come here or it will stay as it is. Any one of them will happen. Suppose this column, this row this column comes here and this column comes here. Then for the first share, the dealer is going to print this. First row, suppose after giving a permutation, it becomes 0 0 1 1. Then to the first row, he is going to print 0 1. To the second transparent sheet, he is going to print 0 1. Now suppose the second pixel is a black pixel. He comes here, gives a column permutation on it, random column permutation. So anything may happen. Suppose after permutation, random permutation, it becomes the same 0 1 0 1. Then he gives the first row here 1 0 and here 0 1. Now what happened when you superimposed one after another? You will understand that it will look like 0, then it is 1 because you are doing the OR operation, then 1, then 1. Now you can understand that this is complete black. It was originally complete black was there. That's why it is complete black. But originally it was white. Now you look like it's a gray. But still there is a contrast difference. As a result, you will able to distinguish this because just now we have seen that in case of the names, like here Aniket name was there. So Aniket A was complete black, but the background was gray, I mean white. That's why it came gray. But still there is a difference between contrast. As a result, you can distinguish this. Is it clear to all of you? Any question till now? Any question? Okay, if not, then we'll proceed to
Sir,
further. Yeah.
so what is the convention of whether doing OR operation or AND operation? What are we denoting black as one?
No, I mean that is one, you need to do some mathematics. So here, if I encode it, like 1 is represented by, sorry, black is represented by 1 and 0 is white is represented by white, then you see that this superimposition operation is nothing but a OR operation. But if you encode it like this, 0, black to be 0 and white to be 1, then the whole operation will be AND operation, just mathematical term, nothing else.
What
They are
is the general
complementary.
convention? Is there any general convention of
No,
doing so, or
usually we denote black by 1 and 0 by, I mean white by 0. That's the usual convention. That's why the whole thing is becoming OR operation, binary OR operation. Okay. Is it clear?
yes, sir?
Okay.
Sir, here only the width will be increased and the height will be same, right?
Yes. So that's a good implementation issue. So that's why to make a parity of it, suppose my original image was like this. Okay. Now if you just encode like this, then it will be twice here because it has increased twice. For each pixel you are giving twice. The length will be the same. Suppose it was the length. Okay. So the length will be the same here, but it will be increased in that way twice, 2 times. So sometimes it may happen that the aspect ratio, we call it in image, we call it as aspect ratio. The aspect ratio will be distorted in that way if you do like this. That's why what we'll do, instead of doing only this, you will do in that way also. So we just do like, suppose you want to put it here 0 1 0 1. So here also put the same thing, 0 1 and then 1 0 0 1 0 1. Okay. Now you see that you have increased here twice as well as you have also increased here twice. When you are going to superimpose them, what you will get? You will get a bigger image. So 0 0 1 1 0, sorry, 1 1 1 1. So you can understand that the number of blacks are here 6 and the white is only 1 or 2. But here the aspect ratios are maintained. So you can understand now this aspect ratio has been increased. That means you are increasing here 2 times as well as here 2 times. So original image will look like, the superimposed image will look like this. That will be your superimposed image. So the aspect ratio portion, while implementing it, you also need to think about the aspect ratio as well. Clear? Any question? So if not, then I will stop it here. So from my chapter 12, please have a look at this, and that can also be extended to 2n schemes by using some statistical designs known as BIBD and PBIBD that are already in my book. So please have a look at chapter 12 of that book, and that will help you to understand. Okay, so that's all about visual cryptography.